Okay, so we are going to go over 4 different topics today. We are going to look at x-intercepts, factoring, multiplying, and table of values. Now, these are all related, although that probably won't look like it today, but let's try it anyway. Okay, let's start. I'm going to change it up. Let's start with, let's start with multiplying, okay? We're going to start with multiplying. All right, now when I say multiplying, what I mean is multiplying binomials, which is a type of distribution. All right, so we can talk about distributing and distribution. So this is something that I'm pretty sure you've seen before, and it would look like this. We would say like x plus 2 times x plus 4, and I would ask you to multiply this together. So the way we do that is you're going to take the first term in the first bracket and you are going to multiply it through the entire second term. So x times x is x squared, and then x times 4 is 4x. And so now we've multiplied the first term by both of the terms in the second bracket. So we're going to do the same thing with the 2. 2 times x is 2x, and 2 times 4 is 8. So that's kind of the first step. Then we're going to go back through and we're going to collect like terms. And do you see how I have 2 x's? I'm going to put those together. So there's only one x squared, so x squared. 4x plus 2x is 6x, and then 8. So that's what that looks like. That's called multiplying binomials, or we also refer to that as distribution. So let's look at a slightly more complex example, shall we? What if we have, I'm really just kind of going to go for it here. What if we've got 2x plus 3 times x minus 5? We're going to follow the same thing, and we're not going to let the negative mess us up. So we're going to start with this 2x, and I'm going to multiply it by both pieces. So 2x times x is x squared. 2x times negative 5 is negative 10x. Now I'm going to move to the 3. 3 times x is 3x. And 3 times negative 5 is negative 15. Combine your like terms. Right here, you've got the x's. So x squared, negative 10x plus 3x is negative 7x minus 15. And that's your answer. Okay, now, the reverse of that is called factoring. So let's say we had this, and I asked you to factor it. That means you're going to take this and you're going to reverse it back to the 2 brackets. Or up here, you're going to reverse that back into its 2 brackets. So factoring is like a type of division, right? Because it's the opposite of multiplying. So let's just focus on this one for a minute. I want to ignore this bottom one. Look at a couple things that happened here. This 8 came from the 2 and the 4 multiplying together. And this 6 came from the 2 and the 4 adding together. So that's a big clue, and that's basically how we're going to figure this out. So let's take a look. If I give you this, x squared plus 7x plus 12. And I ask you to factor this. Factoring means you are going to make 2 binomials, so 2 brackets. And in each bracket, you need a first and a second term, so we're going to fill in these spots. The way we start is with this x squared. We are going to need an x and an x in both brackets to multiply together to get this x squared. So you can just go ahead and start like that. After that, we are going to look at the 12, and we are going to ask ourselves, what are the factors of 12? What multiplies to 12? Well, 1 and 12, 2 and 6, and 3 and 4. These are our options. And then we're going to ask ourselves, which of these add to 7? So we need something that adds to 7. So 1 plus 12 does not add to 7. 2 plus 6 does not add to 7. But 3 plus 4 does add to 7, and that would be a positive 3 and a positive 4. So then you're going to come over here and you're going to say x plus 3 and x plus 4. And you're done. And you can always check your work by multiplying backwards. X times x is x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. Combine like terms and you get x squared plus 7x plus 12. And that's exactly what I started with, right? So therefore I must have done it correctly. Okay, let's try another one. What about this? What if we have x squared, I need to get crazy here, minus 3x plus minus 10. Okay, so see, now it's all messed up because we've got negatives everywhere. But we're going to follow the same steps. If I ask you to factor this, you're going to make brackets. And you need 2 things in each bracket. And the first one you automatically know is that you need an x and an x. Now you're going to come over here to this negative 10. And you're going to ask yourself, what multiplies to 10? And you've got 1 and 10 and 2 and 5. However, this is a negative 10. So one of these numbers is going to have to be negative. The question is which one? So to figure that out, we're going to come over here to negative 3. And we're going to ask ourselves, can we get this to add to negative 3? And we're going to need a negative, right? Is there any way 1 and 10 can add to negative 3? No, not a chance. So they're out. 2 and 5, can we get them to add to negative 3? Yes, but how do we get them to add to negative 3? So you have to be careful. Are you going to say negative 2 plus 5? Or are you going to say 2 plus 2 and negative 5? Which one will give you a negative 3? See, negative 2 plus 5 is actually positive 3. But positive 2 minus 5 is negative 3. So this is what we need. So we're going to come up here and we're going to say plus 2 minus 5. That's it. Okay, so that's 2 things off our list today. Now, the next one we want to look at is x-intercepts. So x-intercepts are on a graph, and we're going to look at linear x-intercepts today. So x-intercepts occur in a very specific place. Now, typically, we've been looking at problems like this. Like this would be, let's say, negative 2x plus 4. And this plus 4 has been our y-intercept, right? This is our y-intercept. It's a very important place on the graph. However, there is an arguably more important place on the graph, and that is the x-intercept. So the x-intercept is the place where your line crosses the x-axis. So this line right here, this black line I'm drawing, is the x-axis. So wherever your line crosses is the x-intercept, and it's muy importante. Now, think about this. The y-intercept, the coordinate at the y-intercept is like 0 and 4. So the x value in a y-intercept is always, always, always 0. Because to get to that point, you don't go up, right? Like you don't go left or right. So y-intercepts have to have an x that's 0. Same deal, x-intercepts have to have a y that is 0. That is definitely not a 3. Whatever, for argument's sake. The y has to be 0 in an x-intercept, okay? Has to happen. So therefore, we can always find x-intercepts, and we can do that by replacing the y with 0. So hear me out. That means if I give you this function, if I give you y equals 2x plus 6, you know that the y-intercept here is at 6. You know it's at 0, 6. And actually, the reason you know that is because if you substituted in a 0 here, you would say y equals 2 times 0 plus 6. Well, 2 times 0 is 0, so y must equal 6, right? So what if we want to do the same thing but with the x-intercept? We would take a 0 and plug it in for y. So I would replace my y with a 0 and then solve for x. So I need to move my 6 over, so now I have negative 6 equals 2x. Divide out my 2, and sure enough, my x-intercept is going to be at negative 3. So this would be a coordinate of negative 3, 0. And the reason I get that is because I put in a 0 for the y, and then I figured out what x went with it. Cool? You can do that for anything, but the key is, let me write this down so there's like a really good thing to screenshot. X-intercepts happen when y is 0. And then you solve for x, okay? Screenshot that. Super important. Okay. Let's keep rolling with 2x plus 6. If we have y equals 2x plus 6, you can always figure out how to graph something with a table of values. And a table of values looks like this. It's called Table of Values. And a table of values has a list of x's, and then you figure out the list of y's, and then sometimes over on the side we show our work. You can literally pick any x in the whole world. And if it were me, you should always pick some negatives, a 0, a 1, and a 2. And what we're going to do is we're going to take each of these numbers and we're going to plug them in. So these are x's, so I'm going to plug them in for x. And I'm going to do this one at a time. So I'm going to say, let me write down my work. I'm going to say 2 times negative 2 plus 6. And that equals y, right? So negative 4 plus 6 is 2. So 2 equals y. So I'm going to write that here in my y column. Okay, so 2 times x. So now I'm going to do negative 1. 2 times x. So 2 times negative 1 is negative 2. Plus 6 is 4. 2 times 0 is 0. Plus 6 is 6. 2 times 1 is 2. Plus 6 is 8. And 2 times 2 is 4. Plus 6 is 10. Now these all become coordinates. So these are coordinates that we can plot. So like negative 2, 2. Negative 1, 4. 0, 6. 1, 8. And 2, 10. So you can come over here and plot those. So you're going to go over to negative 2 and up to 2. Plot a point. Over to negative 1, up to 4. Plot a point. Over to 0, up to 6. Plot a point. Over to 1, up to 8. Over to 2, up to 10. And it should give you, if you're not a terrible grapher like me, a nice linear line. And sure enough, in theory, where is our x-intercept? Our x-intercept was right here at negative 3. Sorry, I have a frog on my throat. Which is what we found a few minutes ago, right? There it is. So you can make a table of values anytime you want. You just pick some x's, pick some negatives, a 0, and some positives, plug them in to figure out what y you get in those create coordinates. Okay, that's it. We're going to practice this now. Good luck. You guys are great.